The second problem is motion when the object is thrown at an angle from the ground. Usually it's a soccer ball that's been kicked at a certain angle, or it could be a golf ball, it could be anything of that nature. The object then travels in a parabolic path, which is actually very symmetrical. It has a distinctive maximum, let's say right here. Actually, question about what's the maximum height is a very common question. So we should set this inquiry as we are interested in the time of flight. We are interested in the range. And just as a reminder, range is how far the object fell from the original position. And we are interested in maximum height. So those three things. We should probably introduce some numbers. Suppose the angle given was 40 degrees and the initial velocity was 9.4 meters per second. Just the two things, and as you can see, we'll figure everything out from the two things. First, before I go ahead, let me just work with velocity vector and break it down into components. So this will be horizontal component, v initial x. This will be vertical component, v initial y. And the angle is 40 degrees. Initial speed. So by the trigonometry rules, x component is v initial cos 40 degrees, y component v initial sine 40 degrees, and I can just go ahead and calculate numbers, given that initial speed is 9.4. I invite you to hit the pause here and actually do the calculations on the calculator just to make sure that you're getting the same answers. And when I actually calculate that, I have 7.2 and 6 meters per second, respectively. Then I go ahead and write my equations of motion. As I mentioned before, horizontal displacement x is v initial x multiplied by time. And you can see there's no acceleration here. It's a motion with uniform motion, basically. And y, I had y0 in the previous scenario, but I don't need it here because there's no initial height. So I start with vi y multiplied by time minus gt squared divided by 2. So those are two equations of motion. I can put my numbers in now. Note that I don't have many numbers, but let's see. I have initial 7.2 time. I have initial on y 6. I always know 9.8. So actually, second equation looks quite favorable. And now we will write one secret line, actually knowing that this is my origin, 0, 0. X is facing this way. Y is facing this way. And my ball starts from 0, 0. It goes up and then lands back again to a 0 with respective of y axis. So vertical displacement is 0. So y equals 0 at landing. And we have somewhat quadratic, but at the same time, quite a simple quadratic equation. So I can actually factor out t if I want, and I will have 6. This is 4.9 t as far as I am remembering. There will be 2 roots, one of them t equals 0, which I have absolutely no interest in because it's pretty obvious that from time 0 ball is on the ground. I'm more interested in this scenario, when is the other time when ball is on the ground. So it's this piece, and I am following step by step and finding time, such is 6 divided by 4.9. So hopefully it's about 122 seconds. Always have the calculator handy, always check that it is what it is within your following. Okay, so we found the time of flight. Let me write this again. And now we can proceed to find the range, how far the object flew, which is found by the x equation. So let's say range is x equal 7.2 multiplied by 122, 8784, which I will round up to 8.8 meters. Or how about I do it in pink? Okay, so lots of good things we found. Time and range. Now we need to find the maximum height. There probably are many ways to do that. I'll show you one kind of very tricky one, but at the same time is easy. Look at this. The ball started from 0, landed here in 1.22 seconds. So clearly the maximum height happened at half time. So we need to divide 1.22 by 2. And let me write that. Maximum height happens at half time. So we divide 1.22 by 2, and it becomes 0.61 seconds. So basically at 0.61 seconds, if we are able to find the vertical position of a ball at 0.61 seconds, then we just find the height. So question, which equation describes the vertical position of the ball? Vertical position of the ball is y equals 6t minus this. Treat it as just the equation of a parabola. If you put 0.61 seconds instead of time, you'll get the vertical position of the ball at that time. So when time equals 0.61 seconds, y equals 6t, 6 multiplied by 0.61 minus 9.8 times squared divided by 2, then you should proceed to use your calculator with caution and care, because it turns out that not many people can figure this out on the calculator. But then when you eventually do, you get the result of 1.83 meters. And that is the maximum height. So once again, we found the time of flight, how far the ball will fly, and the maximum height. Then the maximum height happens at half time. It also happens at half distance, and many people try to figure out the vertex of this parabola. Absolutely not necessary. To be strictly speaking, these are parametric equations of this parabola. Both x and y depend on time, so please don't try to find vertex. It might be a little bit more complicated than you had thought it would be. And just use this trick that I'm showing you, that maximum height happens at half time. Just find half of the time, put it into the y equation, and you have your answer right here.